Greetings, welcome to the Get Solution India. So in the last lecture we have discussed about the differential amplifier and the last lecture particularly we have discussed on the characteristics of the differential amplifier, and we found that the characteristics of the differential amplifier, we drawn the characteristic between input and output, and we found that the characteristic for V1 minus V2, these are the inputs, this V1 input, this V2 input, and we found that the characteristics may be inverting or non-inverting. Okay, so according to the characteristic, we found that this characteristics look like this. So this is the characteristics for V1 comma V2, okay, for different voltage, or sorry, this for Vx and Vy, and we also find the characteristic for this input versus current I2. So we draw the current ID1 because here there is a current ID1 and there is a current here ID2. So there are two current here, and this is the ISS. So this ISS nothing but ISS is equal to ID1 plus ID2. So this is the summing node, or you can say that this is the P node. Okay, so we just giving a name, this is the P node. So this is the ISS, and we find that the characteristic for this currents, ID current is look like this, and the crossing point at this line. So this is the characteristics for ID1 and ID2. Okay, so these are the characteristics for the differential amplifier. Now we will discuss the different parameters with respect to the input voltage. Okay, so what are the input voltage here? The input voltage in this case, differential amplifier are two input voltage. We already know that V1 and V2 are the input voltage. We can also say that this is V in 1 or this is V in 2. Okay, this is V in 1, V in 2. So first we will find out Vx minus Vy in terms of V in 1 and V in 2. So we will find out this, and after that we will find out ID1 minus ID2 in terms of V1 minus V2, because these are the outputs. Vx, Vy and ID1, ID2 are the outputs. Only inputs are the V1, V in 1 and V in 2. So we need to find out these quantities, because this is a differential amplifier. So we can take a output the differentially Vx minus Vy, or here we are applying a input at differentially inputs V1 minus V2. So we need to find out the relation between output and input. Okay. So from this diagram, this is very small diagram, so it's not looking very good. I will clarify this. So I am removing some parts. This ID1 is equal to RD2. Okay. So the flowing current here also ID2, and flowing current here also ID1. So this is ID1 and this is ID2. Okay. So if we look from here, so this is the output Vx should be, so Vx should be Vx is equal to this VDD minus ID into RD. Okay, this is nothing but ID1. Okay, and the output at Vx should be current flowing minus this ID VDD. So Vy is equal to VDD minus ID2 into RD. Okay, so from here we can easily find out Vx minus Vy or Vy minus Vx, anything. So here we can find out the differential voltage. Okay, so Vx minus Vy is equal to, okay, this will cancel out. Okay, so we will get minus ID1 RD plus ID2 RD. Okay, so from here we will get RD is common. Okay, so ID 1 ID2 minus ID1. So we will get like this. Okay. Or you can write ID1 minus ID2 minus of ID1 minus ID2. Okay. So we will get like this. Okay. So now Vx minus Vy. This is the Vx minus Vy. Okay. But we know that what is this current ID? This ID current is drain current of the MOSFET, and we know that the drain current of MOSFET is equal to ID W by L 1 by 2 W by L mu n Cox, okay, VGS minus VTH whole square. Okay, so what is this VGS? In this case, this is your gate, this is your source terminal. So here VGS is equal to V1, okay, because this is the current source. So just it is grounded, okay. So from here we can easily write VGS is equal to V1, okay. So from here we can write ID is equal to, or ID1 is equal to 1 by 2 mu n Cox W over L V1 minus VTH whole square. Okay. So similarly we can write equation for ID2. ID2 is equal to 1 by 2 mu n Cox W over L V2 minus VTH whole square. Okay. So just put this value in this equation number 1. So we will get Vx minus Vy is equal to, okay. So for example, this two transistors are symmetric, so minus Rd, okay, and we will take common 1 by 2, we will take common 1 by 2, we will take common mu n Cox and W by L. So the mu n Cox W by L, okay, this is common. So we will get this minus this, okay. So ID1 is this minus this. So here we will get V1, okay, minus VTH whole square minus V2 minus VTH whole square. So in this way we can easily find out the Vx minus Vy in terms of V1 minus V2. We just calculate the each and every parameter, so we can easily find out. Okay. Similarly, we can also find out the value for ID minus ID. Here ID1 minus ID2 is equal to Vx minus Vy, and we will put the value of this. So in this way we can find out all the parameters, the large signal parameter of this device. Now we will discuss the small signal parameter of this device in this lecture.